So now this is IP4, of course. So like as you can see here is the protocol version, which is 4A, is 4. We understand that's why we call it IP4. So it's 32 bits addressing system, supports 4.3 billion unique addresses. Example. Yeah. So this is the major reason why we are here to migrate to IP6, because this IP4 is yet to fit up. So that's why we are seeing IP4, and that's why in this training we might not even talk much about IP6, because this IP4 is what many organizations are using now. So we stick to it, and everything that we'll be doing in this training is the way we are doing it in organization that we are working with. It's not that maybe we are not doing anything theoretical, though theoretical part of it is very, very important, which is what we want to do part of it today. It's very, very important, so we can use the knowledge of theoretical parts to understand the practical part of it. So it's very, very important. So I want everyone attention to, not every one of us, to pay attention to this part of this training very well, because it's very, very important. I know many of us understand IP4 very well. I understand that. I understand, but at least just listen very well so we can ask ourselves questions and try to understand what IP4 is all about. Yeah. So now I'm going to start now. So IP4, I said, what is IP4? No, let's just imagine every houses in the world need home address. So the postman, like the postman know where to deliver letters. I want to use letter and the houses to represent IP4. How IP4 works. So now home addresses, we all understand what everyone have their own home addresses, and we all know the postman, the job of postman, what the postman does, of course, to deliver letter to everyone's houses. So now imagine every houses in the world needs a home address, so the postman know where to deliver the letter to. That's exactly what IP4 is all about. It's a home address for your phone, computer, tablet, and anything that uses internet. There is no way you can access internet without IP4 system. IP4 address system. There's no way. It's an address. That's why I'm using home addresses to explain this very well, so we can understand the overview of what IP4 is all about. So now I said is a home address for your phone, computer, tablet, and anything that uses the internet. IP4 look like this. This is it, and you will understand. You don't need to cram anything. By the time we finish this part of the training, of course, you will understand how to form how the private IP addresses, the public one, and what we use both for. You will understand very well. Yeah. So now IP4 look like this, as you can see from here. Look like this, and just like house addresses have number, so all devices does have their own IP addresses. The structure of our IP address divided into 4 octets, as you can see. So now this first octet, as you can see, the second one, this white, then this 0, the third one, and this fourth one, which is this one, is the fourth one. First octet, this is 192.192 is the first octet. Then the 168, second one, 0, third, and this one is fourth one. Yeah. So now let's proceed. Just think of this IP address as this particular one, like house address broken into 4 parts, which is this that I just explained here. So now I'm going to, just like what I explained here, this particular one, if you can see my screen, please. This is 192, which is the first one, and this is 168, the second octet, 0, the third one, and this one, the fourth one. So like I said, each part of this is called an octet. That is divided into 4. 1, 2, 3, 4. That's it. And they can each go from 0 to 255. Of course, this 192 can start from 0 to 255. This 192. And this 168 is between 0 and 255. This 0 is between 0 and 255. That is, when you remove the first one and the last one, when you remove it from it, if you remove 2 from 255, I think we have something like 243, right? 252. Right? So the rest is what we can, is number of devices that can make use of the IP address. So imagine you multiply 254 or 255 multiplied by this 4. That's the number of devices that can be connected to this particular IP address. But this one alone. So now let's proceed. So we are going to talk about the subnet mask, of course. And this one, okay, this particular one, we have each octet range from 0 to 255. Of course, this is it. Written in dotted decimal format. Of course, all this jargon that we have here is talking about 192.168.0.1. And here, binary representation 8 bits per octet. Of course, that is, this one is telling you this 192 is 8 bits, and this 168 is another 8 bits. This 0 is 8 bits, and this one is 8 bits. Of course, we are going to understand. We understand everything as we proceed. Okay, so we have subnet mask. Let's talk about this subnet mask very well. So now, see the formula here. It's very simple. You don't need to cram anything at all. You don't need to cram anything. This is the formula. Of course, 192.168.0 is network. That's the network part of this IP. Of course, we understand that we have this O1, this one. This is the whole IP4. We understand that one very well. So we have 4. 1, 2, 3, 4. We have this 1 and this 1, 2, and this 1, 3, and this 1, 4. So the first 3 of it is network, is for network. That is, this particular one, this one are for the network. This first 3, this particular one, as you can see here, is for network, this one, and the last one, which is this one, is host, as you can see here. You will understand how we come about all these things. Let's just proceed with it. So this is the host, and the first 3 one is the network, while the last one is host. So it can be, this one can be 1, it can be 2, up to 2255. It depends. It can be 255. This 0 can be anything between 0 and 255. So that's just about that. Network and the host. That's what we have. So we are going to talk about the subnet mask now. So this subnet mask, as you can see, we have 2 raised to power n. Let me just put it like that. You just my normal formula that I use to train people. You might not see it anywhere, but that's the formula. If you want to understand how we come about all these things, this is it, as you can see here. So this 2 n raised to power 5, as you can see, this is 1, 2. It's just like it's a binary, as we understand. So this one now, if you put it on this one, anything raised to power 1, as you can see, this is 1, this 2, this 3, this 4, this 5, this up to 8. Since we talk about is octet, which is 8. So now, let's say, since it started from 0, 2 raised to power 0 in mathematics, anything raised to power 0 is 1. That's why we have this one here, as you can see here. Then anything raised to power 1, as you can see, is that particular thing, which is 2. 2 raised to power 1 is 2. I will give you this document so you can understand. I just want to talk about this place so you can know how you will know how we get all this octet and all this IP4 or IP5. So now, as you can see, anything raised to power 6, what we get, we put it down. Then anything raised to power 2 raised to power 2, as you can see, is 4. It's particularly is this one. Then 2 raised to power 3, of course, is this one. Then 2 raised to power 4 is this one, which is 16. Then 2 raised to power this is this 32. And 2 raised to power 6 is this 64. And 2 raised to power 7 is this 128. I will explain why I did everything like this. You will understand later. Let's proceed. I'm trying to explain what is subnet mask is all about. As you can see, this particular one is subnet mask, which is 255.255.255. This is IP address in decimal format. This form is called subnet mask, as you can see here. So I want you to understand that what we have in that particular area, which is this particular one, is also derived from this one. I want you to understand this 192.168. This one is for this particular one. While this second one is also for this particular one. This 0 is this one. And we talk about that. This is between 0 to 255. That is, this particular one is between 0 and 255. And this one also is between 0 and 255. And this 0 is between 0 and 255. And this one is also between 0 and 255. So I want you to understand that very well, very well. So now, I want to do a little calculation, how we get area that we are talking about. Now, let's start. The first calculation we did here, we arrived to this. This is the formula we started with. We want to calculate the subnet mask. This is the formula we started with. And the whole thing as we talk about here is an octet. Is an octet. As you can see, this is it. It's an octet and it's 8 bits. So, and since we use 8 bits to calculate this, of course, I want to show you how we use this 8 bits. This particular 8 bits, but let me call it 8 bytes to calculate this. So now, as you can see here now, so this is it now. The 128, which is 2 raised to power 7 that we got from the previous slide. So now, We want to know how many times can we see this 128 in 255. How many times can we see this 128 in 255? Of course, it's 1. So we put that one down. This is it. I want to, you will see, we want to calculate, we want to combine it to binary. That's our goal here. We want to combine the whole thing. This thing, what we got, we want to combine them, everything to binary. This is it. Now, so now, if you remove this 128 from this 255, we get 127. So now, you now say, how many times can we see this 24? As you can see, the second number here, which is 24, which is 2 raised to power 6 here, this particular one, and this one, and this one. So now, 2 raised to power 6 is 24. That's the next thing to do. How many times can we see? Since we remove this one, we are remainder is 127. How many times can we see this 64 from 127, which is 1 as well? Then, when we remove this 64 from 125, we got 263. Then the second one, which is 2 raised to power 4, of course, 2 raised to power 5 rather, which is this one, 32. Then how many times can we see this one inside this 32 inside 64 is 1. So that's how we proceed until we reach the final one, which is 0 raised to power 2, which is 1, as you can see here, which is 1. So 255 into binary is 1, 1, 1, 1, 1, 1, 1, 1, which is what? 8 bytes. That is 1, 2, 3, 4, 5, 6, 7, 8. So that's how we know that every IP is what? 8 bytes, as we can see from here. And we also derive that every byte here is called an what? Everything here is called an octet, as you can see, divided into 4 octets. 1, 2, 3, 4. Why this is very, very important? Of course, this is what we have as an IP. Ordinarily, we have this, something like this. This subnet mask. This is what we have. In any organization that you find yourself, if you want to start any organization now, we have this. So by the time you now split it to something like this, we now call it segmentation. That is, you split it so many devices can be connected. Let's, for example, in a case study, let me just use a case study. I know most of us are already working with an organization. So if you go to your IT department, you will understand that if I'm talking about standard company or not just startup, I'm talking about standard company. You will understand that the sales departments have their own IP addresses. You will understand that the IT department, they have their own. Other departments, operation department, they will have their own IP addresses. So HR department, they're supposed to have their own IP addresses. So that's what is called segmentation. Segmentation is very, very important in the sense that, let's for example, Anaka, I'm very sure now that we are training Anaka here. All of us here, I believe we are even though if by now we are not yet to be an ethical hackers person, very soon before the end of this training, we should be able to be proud of ourselves that yes, I can do this. I'm an ethical hacking or whatever. So now this subnet mask is for us to divide. Okay, let me just put it in this way. Let's pretend a town wants to split its home into neighborhood. I know. Let me just. I know Lagos very well. So let me just use it. Let's pretend that a town, in your town where you are now, they want to split its home into neighborhood. They want to split it into neighborhood. The subnet mask tell us which part of the address is the neighborhood and which part is the house number. So you understand. So now, for example, now if you are in Lagos, Ikeja is not Ikeja. It not supposed to have a house number because it's a neighborhood. But inside the Ikeja, we have different streets. I just want you to picture the whole subnet mask. Inside the Ikeja is a neighborhood. You want to split that Ikeja into different streets. So you understand. So that street, each house in that street has their own house number. So what I'm just trying to say here is that every device have a unique IP address. So let's assume now that this is what you have, and you now want to we want to convert it to subnet mask, which is all this one that you can see here. We want to convert them into all this one, IP4, all this one. We want to convert them to something like this, to something like this, to something like this. Of course, all this one, you will split them. There are subnet masks before, like this, like something like this. So if you now split it to something like this, all this one, all this, every device now we have a very unique IP addresses, as you can see here. If you connect your phone now, it will be an IP address will be assigned. An IP address will be assigned to your phone. So your phone IP address will be different from my own and will be different from every individual in that organization. So that's why subnet mask is very, very important. Let's proceed with the whole thing. The bigger area is called network, in which I've explained earlier. This bigger area here is called network. Let me just mark it like this. This is called network. I will explain this private IP and public IP. I will explain everything. It's called network. Why the last one is the host. Then 255, for example, this 255.255.255.0, 255.255.255.0 means the first part, like this, the first three parts, which is this one, 255.125.255.0. These first three parts here, like I said, I want to relate it to our environment now, so we can understand is the neighborhood. This place is the neighborhood. In IT, it's called network. Is the neighborhood. That is, inside neighborhood, we have different streets. So that's why we call it network. So inside this network, we have different thousands of IP inside it. So now, and the last one here is your house. This one is your house. This is neighborhood. The first three here is the neighborhood. Why the last part is your home house, which is house number. And in network, in internet, we call it host. So let's proceed. You understand very well. So subnet mask in binary, of course, in which I've explained everything already. I've explained the binary, how you can get that. I've explained everything. I want us to go to here, what we have here. So this arrangement that we have here, we call this CIDR, which is classless interdomain routing. So this is the classless interdomain routing. So now, let me just explain. We call it classless interdomain routing notation. Let me just explain. CIDR is like shorthand for subnet mask. It's a shorthand, nothing much. Nothing much here, nothing much at all. Nothing much. So, nothing much. So, instead of writing 255, instead of writing something like this, the whole thing like this, instead of writing like this, of course, we can simply say like this, 192, in which we have already seen, 192.168.1.0, then /24. Instead of writing it like this, I will explain this, how we came about this 24. I will explain everything. But instead of something like this, you can put it like this. That's why we call it classless interdomain routing notation. That's why we call it like that. Instead of something like this, we put it like this. And I will show you why. So now, that 24 means 24 bytes. This 24 here, as you can see, this 24 is bit. It stands for that 24 bits, as you can see here. So now, let's assume that this particular one are for the network, which is for this first theory one. It's for network. This one that you can see is for network. This first theory here is for network. So anywhere you see something like this notation, you know that this one is for network. This 24 bytes that you can see here is for network, as you can see here. So now, let's proceed. So let's assume that we have something like this. We have 8, which is first part. Let me just put it like this. First part is network. You understand? Just let me finish. Then if you have something like this, /16, I think it's next. 16 is next, which is called to first 2 part. I will explain are for network. Then this one, you will understand. I want you to understand what I just said above. So that's why I'm just trying to put this one down. 24. Then it's called to, let me just put, it's called to, it's not dash. That's first 3. First 3 part is for network. Now, what I'm saying is that sometimes you might see something like this, in which you will see when you get higher, when you are working with any IT department, you will see something like this, because I want you to understand. That's why I'm just trying to put it like this, so you guys can understand very well. So sometimes you might see something like this, 16. If you see something like this, 192.168.1.0/24, you will know that the first 3 are for network. That is, these first 3 here are for network. I don't know why this thing is not colored. I can't color this thing. So this first 3 is for network. If you see something like this, anywhere you see /24, that's simply what it means. Then the rest is host. So anywhere you see raised to power 8 like this, you know this is the first part Only this one is for network. The rest is for what? Host. This 1.2 is only this 1.2.192 is for network, while 168.1.0 are for host. So anywhere you see something like this, /16, you know that is first 2 is for network, then the rest is for host. So that's simply what I'm just trying to explain here, as you can see here. Like I said here earlier, I said this first 3, if you see something like this, is for network. That time I use neighborhood and your house and your street. This one, if you are saying Lagos, this is the whole Lagos. Then maybe you are now saying it as Ikeja. This is your Ikeja. 0 here. So this one is the whole network. In 90, the whole thing here is network. While the last one is host. It can be 2555 as well. Let's just leave it like this. This one is host. So now I now say that this subnet mask, we split it into subnet masks here. So now here now we have 192.168, 192.168.1.0/8. So now this 8 is 8 bytes, like you guys said, as you can see here. So now I now said that this one I said earlier from the beginning. I said the whole thing here, that's what I calculated above, is what? 8 bytes, as you can see here. So now this one is also 8, this one is also 8, this one is another 8. So now here now I now say if you see something like this, it's telling you that the first one is only for network, which is what I put here. The first part is network, while the rest is for host. Because this one, the whole thing here is 8 bytes, 8 bit, 8 bit, another 8, another 8, another 8. So if you now see 8 here, it shows that it's only representing this first part. Then 8 plus 8 is 16. If you now see 16 in the next, that means these 2. If you now see 24, that means these 3. 8 plus 8 plus 8. 8 times 3. So you understand? Since this first one is 8 bytes, the other one is 8, the other one, the next one is 8, and this one is 8, and we have 4. Oh. So since it's 8, that means this first one, if you see 8 like this, they are telling you that first part is network, the rest, which is this one, are for host. If you now see 16, that's 8 times 2, which is this one, and this one, these 2 together. This is it. This is it. You understand now? I said that this 8, and this one represents 8, 8 bits, another 8, another 8, another 8. So I now said that anywhere you see 8 simply mean only referring to this 192 alone. It referring to this 255 alone. It referring to this one alone. It referring to this one alone. And referring to this one alone. If it's 8. First part is network, which is this one. If you want to configure network in your organization, the first part is network. The rest is for host, which is this 31 are for host. This 3 for host. Then anywhere you see 16 like this, you will know that 8 plus 8 is what? Is 16. 8 times 2 is 16. It shows that they are talking about the first octet and the second octet. That is, these 2 now are for network. Then the rest is for the host. I now say that anywhere you see 24 here, you don't need to cram anything at all. Anything 90, you don't need to cram anything. The only thing you need to cram, I will tell you when we get there throughout our training, which is OSI model. We call it OC model. That's the only thing that you need to know the level. That's the only thing in IT. You don't need to cram it. Even in programming, you don't need to cram any script, anything. In as long as you understand the basic and everything, the rest will be very, very simple. That's why I want us to take our time to understand this. So now that you understand this now, if you now want to hack anything, if you want to go to networking, if you want to go to cybersecurity or cloud security, anything, you will know that this first stereo is for the network. If they now ask you, maybe you are working in any organization, they now escalate to you that my network is not working, or maybe some department network cannot work, is not working. You will know where to go. You will know the IP to talk about. You will know that once you see it, you see the configuration. Mr. Anthony, my colleague, will show you the network configuration of all these things. He will show you that, okay, this one is for this so department, and that one is for so department. So there's no any confusion at all. So we want to talk about private addresses. So now let me just remove this so we can understand the private network very well. So now, I'm going to also use a case study one all of us can relate with. I will still talk about our environment because I like using our environment because everyone gets environment. One of us day one or two environments, so we get environment. So now, just like some streets are only for people inside an estate, I know some of us know an estate is different from just ordinary street. So I'm trying to explain private IP address range to you guys now. You must understand is a must. If you don't understand and after this lecture you still don't understand, you don't ask that question, then I will blame you for that. When we get to higher level, I will blame you for that. So now, if you don't understand anything, ask. That's why we are here today. So now, I'm about to enter private network now. So now, just like I said just like some streets are only for people inside an estate. We have private IPs that only work inside the home, office, or school. That's just about that. In your house, in your home, presently that we are talking now, you might have your own broadband. Maybe you are using fiber, or you are using SpectraNet, or you are using MiFi. I don't know, whatever you are using. So also in every the one you will use in office is different from the one you will use in your house. The configuration is very different. So now let's proceed. So now these IPs never go directly into the internet. That is, private IP, you can never see them in internet. That's what I was saying when we started. If you are an IT, if you are an hacker, and you are targeting a company, or you want to carry out a pen test, and you are using your own IP to carry out that pen test, that means you don't know what you are doing. That's the meaning. You don't know what you are doing. That's the meaning. Because you should know that private IP, you can't use it to hack anything. It's only public IP that you can use. You should know that. So now let's proceed, and I will explain how you can distinguish between private IP and public IP. So now, since we cannot highlight from here, so I will probably create another. Okay, let me create another one. Private IP. So next slide, so we can relate to it. Private, sorry, IP addressing system. Let me just put it like that. Yeah. So now we have 3 private IP ranges. We have 3. So before I start, I think I put everything here. These are the 3 IP address. We have private IP used inside network. We have public IP. We have private ranges. All these are the ranges, but I'm going to explain, split everything. We have 10 class 1, range 1. We have 1. Let's just put like that. We have 2. Then we have 3. So first one, let's start from first one. Then we have 10.0.0.0, then to 10.255.255.255. I will explain. Then the second one, we have 172.16.0.0, then to 172.31.255.255. Okay, then the class 3, we have 3. Then this third one, we have 192.168.0.0, then to 192.168.255.255. Yeah. So these are the 3 that I want to explain. You will now understand that you don't need to cram anything at all. You will understand. So now, what is a private IP? Like I said, I will always use simple things to explain. I want to take this class as if we don't know anything. I know some of us know more than what I'm doing here. I know. But for the sake of those that do not even have IT knowledge, that's why I'm just doing it as a small baby like this. So now, imagine in a big city, some roads are only for people inside the school or estate. You can't use them to go out or only inside. I don't know if you understand. Imagine in a big city. I say imagine in a big city, and some roads are only for people inside the school or estate. In that case, that kind of road, you can't use to go like that is, use them to go out. You can only use them to go inside the estate or inside the house, inside the school rather. These roads are called private roads. That is, it's only for your street. It's only for your school. Once you enter your school, there's no road again. Once you enter your estate, no road. That's where the road stop. Those ones are called in IT. Those kind of things are called private IP. Those are called private IP. So private IP only work inside your house, school, or office, not on the internet. That's what I want you to understand. All these things that you can see here, they only work. Private IP only work in your school, offices, house. You can't find them in internet. And I will show you why. I will show you something. Now, I want to ping something now. I want to ping that is inside your system. If you are with your system, you can open your CMD, type CMD for your search box. You will see something like this. So this is CMD, command prompt. So now, if you type IP config, of course, you will see something like this. This is IP config. So now, here, you cannot see public IP here. All the IP you can find here are for private IP. You can check, just ping your own. That is IP config. If you are using what is it called? Kali Linux, just if config. Use if config if you are with your Kali Linux to check your IP address. So now, as you can see, all this one, I have them plenty like this because I have a lot of virtual machine on my system. So that's why I'm supposed to have something like one here, but I have all these things. I'm supposed to have something like this only, which is wireless LAN adapter Wi-Fi. As you can see, all this one, this is my IP4. This particular one is for my IP4. This one is for my IP4. Then this is my subnet mask that I was talking about, and this is default gateway, as you can see here. So now this one, this is my special net. If I connect another one now, instead of this one, it will be like 108. If I connect another one, 109. If I connect another one, 1010, up to 254, 255, 254, because the last one is for broadcast. This is my private IP. Now, let's check how to see our public IP. For the sake of, if you want to start, by the time we start doing our pen test. So now, let me just drag this one here. As you can see, if you want to check, you can check on your terminal. But for people that are not with our system that are accessing this thing on phone, so I'm going to show you on internet. Just search for my IP. On internet, my IP. So we always see this. Everyone will always see something like this. So if you click on this, of course, you will see your public IP here. This is your public IP here. You will notice that this one is different from the one I show you using the command prompt. Let me show you something. This is it. This is my public IP, as you can see. This is my public IP. And the one I pinged for you that you saw that time is my private IP. As you can see, this is my private IP. This one can only be assigned in offices, your home, or school. You can't see it on the internet. You can never see this on the internet. So now let's proceed. So we can understand anywhere you see private IP, you should be able to distinguish from private IP. Even though if you are sleeping, if they ask you which IP is this, which is it private or public, you should know. I'm explaining like this in case of some of us that want to go for certification exam. They will show you, they definitely ask you which one is private, which one is public. But if you know without even cramming anything, you will know that this one is private and this one is public. So now let's proceed. Let's proceed. So how do you recognize private IP? And like I said, no big calculation at all. We just need to memo. We just need to know three things. Have it in mind. Just three things to have in mind. So now the three private IP club, I put it in a way that I normally call it club. So the first club, that is club 1. Let me just put it like this. Club 1, like I said, it starts with if IP addresses start with or start like, let me just say start like this. Let me just put it like this, like 10.0.0.0.0. 0.1, or you saw something like 10.100, it can be 100.100.100. You can have something like this, 10.1.2.3. This is the first club. You will see the range now. You will see it's private IP. You know, everything starts with 10, as you can see. 10, 10, 10. Just have that one in mind. That's the first club. As you can see, this one starts with 10.000 to 1. 10.100, 100, 100, 100. 10.123. All this one, anything 10 dots, 10 dots, you will know that this is private IP. Have that one in mind. 10 dots, 10 dots, 10 dots, 10 dots. Have that one in mind. You will notice that. Let me just arrange it so you can understand the arrangement very well. Let's just put it like this. Yeah, so you can understand the arrangement very well. As you can see, 10 dots, you will know that this is private IP. 10 dots, this is private IP. 10 dots, this is private IP. This is our first club. Then the second club. The second club, let me say club 2. So I will not waste our time. Club 2. Anything start if it starts with 172. Anywhere you see 172 at all, anywhere, just see now. 172. And the range, and you see the second range. Second number is, let me say, is between 16 and 31. So you will know that anything you see this, anywhere you see this, let me just put it so you can understand very well. So now, example of this is 172.16.0.1. Then the second one is 172.20.1.1. Then the third one is 172.31.255.255. Yes. Now let's check something now here. So now you will understand that anywhere you see 172, just have that one in mind. Anywhere you see 10, anywhere you see 172, and the second, like what I say here, I say and second number is between 16 and 31. So now the second number is between 16 and 31. So now let's check 172. This one we met this criteria. Then 16. Of course, this one is 16. It's between 16. Then, as you can see, 16. The second one, that's the only thing you need to be mindful of. Let's assume that we have 172 and 15. Who can tell me if you have something like this? 172.15.0.1. So now, the first rule is 10. Anywhere you see 10 like this. And the second rule is that the second club of this category is this. The first must be 172, and the second must be between 16 and 32. Anything outside that is public. As you can see, we have more than 4 billion IP addresses in the whole world. More than that, IP4. So that's why I use the club theory. Of course, the club theory is, let's go for the club theory. The club theory is, let me put it like this. So anywhere we see something like this, start with 192.168. Sorry, 168. Anywhere in the world, in the whole world, any IP, anywhere you are working, and you see 192, you can be verifying this thing using your CMD on your computer or on your phone. You can be verifying it, check your IP, so you can know. You can verify everything. So this one now, example of this club theory now is the three thing that you need to know is 192. Let's do example. Let's go for example here. 192.168.0.1, then 192.168.1.5, then 192. Okay, let me just put 100. Dot 100 is 100. Dot 100. Dot, let's say 200. Now, something like this. This club theory, which is the OIP. This is the club theory. So now, anywhere in the world you see 192 here, anywhere in the world, forget what followed. Anywhere in the world, you see something like this, you know that you are dealing with private IP address. Let's assume that you in your company you are working with, they ask you as an IC to assign to segment this IP for you. They give you something like this: 192.169.0.1 does, yeah, something like this. Let's assume you are working in company XYZ and they gave you something like this. That's all. Because this range is above this. And if it's 167 you have, it's still public because it's not with this range. It's not in this range. So that's, I hope we understand IP, private IP now and public IP, right? So now, our next class, we are going to talk about encryption. We are talking about operating system. Those are the fundamental parts. If you want to go into understand hacking very well, we need to understand this thing that we are talking about. So thank you very much, guys. And I'm very, very thankful for your time. I appreciate your time.